Hello everyone, welcome back to our Algebra 2 class. It's been a week and I really hope everyone had a great time during the break and also took some time to take care of yourself. And today we are going to move on to a new unit. In this unit, we are going to explore two new functions. So the first lesson, we're actually going to learn something about exponents. So somebody already know what exponents is, but today we are going to explore a little bit different kind of exponents, which is called rational exponents. So before that, before the lesson, let's do a quick warm-up. So we are going to simplify the following expressions, and our goal is to have positive exponents. So let's check the first one. The first one is x to the fourth power divided by x to the fifth power. We know when we divide the powers with the same base, we subtract exponents. So it's actually 4 minus 5 is going to be negative 1. But we need to have positive exponents, so what we're going to do is we're going to convert it to 1 over x. This is just a definition of the positive exponent. That's why it's going to be definition of the negative exponents. Whenever it's something to the negative power, we can convert to 1 over to that power. Okay, now let's do the second one. So the second one, as you can see, we have parentheses, we have power of the power. We also have negative exponents. So we are going to break down the parentheses first, and then we are going to see can we combine something? So the first part is m to the negative 2 power. The second part, when we work on the power of the power, is actually we are going to, it's more like a distributive, is distribute the 3 to every single part. It's more like 2 to the third power, this and this. So that means 2 to the third power, m to the 3, m to the third power, and this is going to be m3 times 3. And also the last part is n squared, then to the third power. So when we deal with, for example, when we deal with this, we actually multiply these exponents. We multiply them together. So now let's write them out. So 2 to the third power is 8, and this is multiply. We multiply as 9, and this is 2 to the 6th. And also we know when we have a same base and when we multiply them together, we actually add exponents. So we're going to keep the 8 in front, and negative 2 plus 9 is going to be 7. And the last part is going to be n to the 6th power. You don't actually need to write this dot here. We can just keep the answer as 7 n to the 6th, because this is actually just mini multiplication, so you don't like save this dot here, so we can just write this. They are equivalent form. Okay, so this warm up is just quickly to review some properties of exponents, like how do we divide power, how do we multiply power, how do we deal with power of the power. So next, I just want to quickly just readdress how do we deal with the exponents together. So when we deal with exponents, oftentimes we always check, do we have same base? If we do, then we are going to add exponents. For example, the first one, we add exponent together, and which is to 0. And the very important fact about the exponents is any non-zero number to the 0 power we defined as 1. But please remember, this is not applying this case. This is not equal to 1. 0 to 0 power is called undefined. The reason is it's actually coming from, this is actually coming from when we have the same exponents, same power. When we subtract this, it's going to be 1. But when we divide by the same number, it's going to be 1. So that's why they are defined like this to keep the calculation consistent. However, if you divide by 0, then of course it's going to be undefined. So any non-zero number to the 0 power is defined as 1. And when we deal with expressions with exponents, remember, do not forget the common thing when we deal with numbers. Sometimes students easy to make a mistake like, oh, I'm going to subtract exponents, so I'm going to subtract numbers too. Remember, numbers do a division, so we are going to deal with 15 times divided by 3, which is 5. And this is x to the third power divided by x to the second power. They have the same base, so it's going to be 3 minus 2, which is 1. We can save it. We don't need to write it. For this, sometimes students will make mistake like 2 minus 0. When you don't see any exponent, there is actually indicate there is invisible one. This is just why we save it. 2 minus 1 is going to be 1. So again, we don't need to write it. We don't need to write 1 here. It just no need. We can just, erase this part. We can just keep the answer as 5xy. So some common mistakes I just want to readdress here when we deal with exponents, so we know it's really not working like that way. So, all the warm-up or review here is just to refresh our memory about exponents. But today we actually want to work on a new kind of exponent, which is called rational. So what is a rational exponents? Before we introduce definition, let's check these two expressions here. This is the one we just worked before. We deal with 2, negative 2. However, if you check this one, the little number in the corner, this is now 8 times 1/3. This is 8 to the 1/3 power. So compared to these two, what differences you notice? Some students already noticed that. It's like very obvious. Before we have whole number as exponents, we have 2, we have 0, we have negative 2, we have, all kind of integers to deal with, more like integers to deal with exponents, right? However, this one, instead of, just having integer, now we have rational number, like fractions. So this kind of exponents is called rational exponents. So this time we have rational number as exponents. This is actually the big difference here. So that's why we call rational exponents. Some students might go a little bit crazy here. I know how to deal with like 3 to the second power. We know it's 3 times 3. That means that's 2, meaning I multiply 3 times. If I put 1/3, what does that mean? I multiply 8 to 1/3 times? Now, no, it's not defined like that. It's not, oh, it's 1/3 times, something like that. It's not, okay? So rational exponent is actually coming from the root. What does that mean? So we know square root of 4, which is find the number who multiplies itself twice to get 4, which is 2, right? So this definition, I can rewrite this as the square root, meaning I find the number who multiply the second time, then this one is rewrite is 1/2. So the square root is 1/2 power, which is 2. Okay, but the calculation is actually square root of 4. So this is a definition of the rational exponents. So let's check this example again. 25 1 to the half power, which is equivalent as square root of 25, meaning I need to find a number to multiply itself for twice to get 25, which is 5. So some students might say, hey, what about 1/3? So 1/3, same thing. This one is, remember, square root, we don't put a 2. It's just invisible 2 here. 1/3 meaning I'm going to find the third root of 8. So you are going to think, what number to the third power is 8? Yes, you are right, which is 2. So that's why the answer is 2. That's how do we deal with rational exponents. This is just find the root. So for example, let's give another number. So some student might say, hey, this is 1 to the second, one half, 1 to the 1/3. Then what about fourth? So fourth, same thing, meaning find the fourth root of 16. Again, you are going to ask yourself this question. What number to the fourth power is 16? Which is 2. 2 times 2, 4, times 2, 8, times 2, 16. So that's why this answer is 2. So this is how we deal with rational exponents. Okay, so rational exponents is actually is a root, third root, fourth root, square root. Just depends on what number you are dealing with. Okay, now question is, what if I'm dealing with 3 over 4? So the 3 over 4, one thing I want you look at this number is, I'm going to break down the 3 over 4 as two parts. I can deal with this. I can deal with fourth root first, then 3 power. Because remember, 1/4 times 3 is 3 over 4. I can break down this, or I can break down as I'm going to find third power, then I deal with this. So two ways to write it. This is the fourth root of 16 times 3. This is 16 to the third power, then fourth root. They are equivalent. They are equivalent. It just the order of operation. How do you do the first? Are you going to find the root first, or are you going to find the third power first? But they are equivalent. So my way to do this, I always prefer to find the root if I can, because I don't need to deal with 16 times 16 times 16. It's a little bit complicated to do all the calculation. So for this, we know 16's fourth root is a number who do the fourth power to get 16, which is 2. So I know it's going to be 2 to the third power, which is 8. That's it. That's how do we deal with exponents, rational exponents. So let's quickly review this process again. When we deal with 3 over 4, or whatever the number we have here, we can find the root first, and then we deal with the integer power outside part. So when we deal with root, as we mentioned, we actually do the mental math. One number to the first power, to the fourth power is 16, which is 2. So the inside value is replaced as 2. Then 2 to the third power is 8. This is how do we do this. Let's quickly do another calculation. Let's do 8 2 over 3. So you can actually do some calculation by yourself now. Pause the video, do this practice by yourself, and I'm going to show what do we do here. We do 1/3 power first, then 2. We know 1/3, which is the cubic root of 8, then 2. So the cubic root of 8, as we mentioned, which is 2, so 2 to the second power is 4. That's how do we get the answer. Okay, so use this process to help you to understand this answer, and I hope you totally understand this. So this one is gonna be your first question of exit ticket. How do you finish this answer? My hint for you, finish each part and then see can you find the final answer. Okay, do not forget this little dot here does mean multiplication. So this is going to be the first question of the exit ticket, and you are going to see another problem on the exit ticket. Okay, so this is our lesson for irrational exponents. I hope this video is helpful. You can definitely pause video or review this to totally understand how do we deal with rational exponents. Everything is actually same. The only difference is when we say the fraction, we know we are going to deal with the root part. Okay, thank you so much for watching and studying this topic with me, and I hope you have a great day. See you soon, everyone.